Alrighty, so here we are with the Chapter 4, Section 2. We're going to evaluate the 6 basic trig functions, and we're going to be introduced to the unit circle. So let's see, our 6 basic trig functions, hopefully we recognize these 3, okay? Turns out that these 3 are the flip of the first, so we'll kind of go over how that goes. First, when we're talking about our trig functions, we're identifying that there's an angle somewhere. The angle is never going to be the 90 degrees, so it's always going to be an acute angle that's part of a right triangle. When we look at this, you'll see that this is the adjacent side. All right, next to it here, adjacent to it, our hypotenuse is always the one that is across from the 90 degrees. And then, of course, the opposite side is the one that is across from where you are standing. I like to think of this as where we're standing, so it's a little easier to kind of see that the opposite is over there. All right. If you have that, then we also maybe remember Sohcahtoa. All right. Sohcahtoa has O and H next to your S, which would mean that sine is the opposite side over the hypotenuse side. Cosine has C next to the A and the H, and so that would mean that adjacent is next to, it's going to be over the hypotenuse. And then tangent is next to an O and an A, and so that gives us the fraction of opposite over adjacent. All right, then I did mention that in the next ones they are the flip. So the what this is called is cosecant. So secant, but with a co in front of it, is actually 1 over sine. And 1 over sine is potentially going to be hypotenuse over opposite. Then down here we have secant. And secant is 1 over cosine. And so therefore we have hypotenuse over adjacent. And then we have cotangent, and that leaves us with adjacent over opposite, or 1 over tangent. Alright, so those are what we call the 6 basic trig functions, and so the homework assignment and in the future, they'll ask you something like, give us the ratios, that would just be your fractions, the ratios of the 6 trig functions based on maybe an image or based on giving you one of them. So that is what that is all about. A side note about knowing which one is which, because a lot of people want to put sine with secant, but sine is with the CSC here, which is cosecant. These operations are on your calculator, and I'm just looking for my calculators. Nope, they're not on your calculator, so that's why we have to put them as 1 over cosine. The inverse operation is on your calculator, which we'll talk about in the next lesson. So, again, on that note, sine, I like to call this one, it's dumb, but I like to call it cosecant, okay, because it's cosecant, but then you kind of get the idea that it's CSC. Versus in cosine here, I call this one secosine, just because then I can kind of see that SEC would be secosine versus cosecant. So either way, if those help you, that's cool. Otherwise, you just need to remember which one is the opposite of which one. So that's the idea there. Alright, so what we're going to do here is not have directions, but it is going to ask you to give the 6 trig ratios. So if we are given this setup here, and we give our 6 trig ratios, we've got sine, and cosine, and tangent, and then we've got cosecant, secant, and cotangent. And we are talking about of the theta that they give you, so technically that's here. And so we just need to give the fraction that would make it up. So how do we do that? Let's see, we start out by labeling them. This one's theta, so this is the opposite. Over here is across from the 90 degrees, so it's the hypotenuse. And then over here is the adjacent. So how do we find hypotenuse? We have to do a little side note of the fact that if this is 7 and this is 11, then this is our C value. And so we can use the Pythagorean Theorem of a squared plus b squared equals c squared. So if a is 7, 7 squared plus 11 squared is going to equal c squared, which is 49 plus 121. And so 49 plus 121 is 170, not the best number, and then we're going to square root that. So our C value is about 13.04. Most of the time what we'll do is keep our C value as what it is with a square root, because a lot of times it'll end up canceling or whatever it happens to be. So kind of just up to you in this case, because a lot of times decimals inside of a fraction is actually very weird when you think about it, because decimals are fractions, and so it's a fraction within a fraction. So anyway, so our sign here is going to be opposite over hypotenuse, so the opposite is 7, and the hypotenuse is square root of 170. Alright, then we have our cosine, and cosine is adjacent over hypotenuse, so that's 11 over square root of 170. Wow, that's hideous. Okay, boop, boop, boop. Then we have tangent, which is going to be opposite over adjacent, and so our opposite is 7, and our adjacent is 11. Without having to think too much, especially if you know which one is which, all you have to do for the next piece is just flip the one that is next to it. So 170 over 7 from this one to this one. Flip the next one, square root of 170 over 11, and then flip the last one, 11 over 7. So that's why it's nice to know which one, goes with which, because you just flip the fraction once you took the time to make it. Alright, this next one here is not giving you a picture, but it's giving you a setup. So they're saying that if we have theta, for instance, right here, and our opposite side is here, adjacent here, and hypotenuse here, if sine is opposite over hypotenuse, we have a 3 for the opposite side and a 5 for the hypotenuse side. So we're kind of standing here, and that's where all this stuff is. So we'd want to find the adjacent side, and maybe you remember that there's a Pythagorean triple of 3, 4, 5. But if you don't, then we have a value of 3, a C value of 5, and we're trying to find out the B value. Which means in the Pythagorean Theorem, we would have 3 squared plus b squared equals 5 squared, or 9 plus b squared equals 25, or subtracting out that 9, we get b squared equals 16, and so therefore b is 4. So either way, 3, 4, 5, knowing that one, or calculating, will get you our sine of theta, which we already know is 3/5. Then we have cosine of theta, and then tangent of theta, and then cosecant of theta, secant of theta, and cotangent of theta. So our cosine ends up being adjacent over hypotenuse, so 4 over 5, and then tangent ends up being opposite over adjacent, so 3 over 4. And then we can quickly flip them, and that's going to get us our secant and cotangent and cosecant. There we go. And again, we're not going to simplify those into decimals. That's not helpful, especially if you kind of imagine this setup that's happening here. It's most likely to be helpful if it's already given those top and bottom pieces. So definitely don't want to simplify those too much. Alright, so the next thing that we are going to go over is the unit circle. This is a very tiny unit circle, so I did provide a bigger one in a separate sheet of paper, which I will be going to here. So we're going to identify some patterns here and then fill out the pieces that we have. So kind of actually quite a bit of stuff going on here. So the first thing that we need to notice is that when this is broken up into its pieces, it's actually broken up into unequal pieces. Okay, so if I draw those two lines, what actually happens in the 360 degrees is that each of these is worth 15 degrees. So this would be 45, this would be 60, and this would be 90. And so as we look at where that's supposed to go, this would be 30, this is 45, this is 60, and this is 90. And so we do end up actually skipping 75, and we end up skipping 15. Why we do that is how it is. So you can investigate that further if you would like, but right now that's the idea. Which then brings us to the next piece. So basically any time that you're going to the next few, you would add, for instance, 30 or 15. So in this case there's a larger space, so that's going to be adding 30, which would make 120. Then we have adding 15 here, because that's a smaller space, so we're going to do 135. Adding another 15 gives you 150, but then adding a 30 is going to give you 180, which hopefully we all know is half of 360. So we've got our 90, which is pretty generally known, our 180, which is generally known, and then we continue on with the pattern. So adding 30 makes 210, adding 15 makes 225, after 225 adding 15 is 240, and then perhaps, especially when you think of certain like snowboarding sports or whatever, 270 would be kind of that 3/4 of the way around. And then we add 30 again, so 300, 315, 330, and then adding a 30 again. So this could either be 0 degrees or it could be 360 degrees. So it kind of just depends on if you've noticed that it's been spun around or not. Alright, then we need to do our, instead of degrees, our radians. So how do we get our radians? Well, there is a pattern, especially if you take into account that this was 15 and this was another 15, so broken into, well, the entire thing would be broken into 24 pieces. So to get us started, the first thing you need to know is all the way, halfway around the circle, is pi. Okay, so it's not 2 pi, it's not pi all the way around a circle, that would be 2 pi. So kind of going back up here, you'd have either 0 pi or 2 pi for the 360 degrees, or the 0 if you were doing nothing. So in that case, if we think of it as this being one whole piece, instead of 24 pieces like it is with the degrees, you actually have 12 pieces kind of within this half of the circle. So if there are 12 pieces within that half of the circle, this one would be 1 pi over 12, right? This one would be 2 pi over 12. This would be 3 of the pi over 12, 4 of the pi over 12, and 5 of the pi over 12. Sorry, skipped one. That's 5 pi over 12, and this is 6. Okay. So of course, as we know with fractions, we can go ahead and simplify these. So 2 pi over 12 is actually pi over 6. 3 pi over 12 is actually pi over 4. And 4 pi over 12 is actually pi over 3 if we reduce by 4. And then 6 pi over 12 is going to reduce to pi over 2. So you can continue with that. Whoops, drew a line there. And so this next piece would be 7 pi over 12, and then we have 8 pi over 12, 9 pi over 12, 10 pi over 12 and 12 pi, 11 pi over 12, and then of course 12 pi over 12. So simplifying those, 8 pi over 12 makes 2 pi over 6, no, what am I doing? 2 pi over 3. And then dividing top and bottom by 3, we would get 3 pi over 4. And the next one is 10 pi over 12, so that's 5 pi over 6. And then the next one is just going to be pi. So continuing on, this has, of course, gotten a bit messy here. Alright, so it does continue on after that, and so the next piece that doesn't, of course, exist would be 13 pi over 12. Then we have 14 pi over 12, but those are both even numbers, so that's going to make this 7 pi over 6. You'll notice that our denominators end up being kind of in this pattern. We've got 6, 4, 3, and then from the center out we got 3, 4, 6 again. And so our denominator is going to be 4 here and 3 here, kind of continuing that pattern. Then we'll have 15 pi over 12, and so 15 over 12 reduces to 5 pi over 12. Oh, sorry, 5 pi over 4. And then the next one has a 3. And so from 13, 14, 15, we have 16, which is divided by 12, so that means that we're going to have 8 pi over 3. 16 is 8, oh, but that's not enough. So 4 pi over 3. And then the next one ends up being your 18, because this is 17 pi over 12, and so this is 18 pi over 12. And so 18 pi over 12 becomes 3 pi over 2. Again, just like this previous one over here has a 2 base here. Same pattern happens with our denominators, so we have a 3, a 4, and then a 6 going up here. And so we continue on with 19 pi over 12, 20 pi over 12, so that's going to be 10 pi over 6, oh, but 5 pi over 3. And then continuing on, we have 21 pi over 12, and so if we divide by 3, that's going to be 7 pi. And then we have 22 over 12, which makes 11. And then we get back to the top. So, kind of a way of figuring that out. What I did when I was in high school or memorizing this was mostly just memorize, first of all, that denominator pattern that I talked about, but then also a numerator pattern. So in this one, of course, all of them are pi. In this one, it goes 2, 3, 5. And then in the next one, 7, 5, 4, 3. So it just starts at 7, skips 6, but 7, 5, 4, 3. And then 5, 7, 11. So I did just kind of memorize each of them, but of course the way that you can figure that out is the fact that it's broken up into 24 pieces, 12 on each half, and so that's going to be pi over 12 for that first piece that of course doesn't exist but is out here. Alright, so then we move on to the the coordinate point, okay? And so the coordinate point that exists out here actually comes from, and we kind of talked about it in our most recent Zoom call, but the idea is that it's going to be cosine for whatever the x value is, and then sine for whatever the y value is. So from now on, if we're in the unit circle, cosine represents x, sine represents the y traveling. So, the first thing that we're going to do is kind of talk about being at 0, 0. And so if I want to find what I consider this coordinate over here, I'm going to have to go over a certain distance and up a certain distance. All right. The next one, I'm going to have to go over a certain distance, and then up a certain distance, and then over a third distance to get to this one, and up a certain distance. And so if you notice, what happens is we have kind of these three values here, we have these three values here that represent the length or the height, and they're all actually the same. So the values that they represent are a half, which is 0.5, so that's going to be these first ones here actually that are halfway between. Then we have the next piece, which is square root of 2 over 2. And then we have the third piece, which is square root of 3 over 2. So each of these is going to represent the distance that can only happen within this unit circle. If you want to get those distances, it's because we are finding the hypotenuse, right? And we have this side length and this side length. And the hypotenuse is always 1. Okay? And so you can work backwards to get these values, but that is where it comes from. The radius is 1 of this circle, therefore the hypotenuse is 1. So thinking about it as a coordinate grid, if I want to get to this point up here, I'm going to go over the first amount, so that's going to be a half when it is in order here, from least to greatest. And then I'm going to go up, actually, the most amount, which is going to be the square root of 3 over 2. Alright, then if we go to the next one, we pop over to the middle, so that's going to be the square root of 2 over 2, and then up the square root of 2 over 2. It's right there in the middle. The next one, we're going to go over the biggest value, so that's going to be the square root of 3 over 2, and then up that smallest value, so a half. So as long as we have each of these three values, yes, you can find it algebraically, but as long as we have these three values, we know that those are going to be the distances that you have. It's either a half, a square root of 2 over 2, or a square root of 3 over 2. Then we get to the ones that are kind of our central values, and so those are here and here. Those are actually all going to be regular whole numbers. So for instance, if I go over to get to here, I've gone over 1 unit because the radius of the circle is 1. And I've gone up none. Versus if I went over to this part of the circle, I'd have gone over none and up 1. Moving downward in the unit circle, if I'm trying to get from the origin down to this one here, I'm going to go down, over none and down 1. And then over here, I'm going to go -1, but over nothing, or up nothing, sorry. Alright. So then we're going to fill in the coordinates for the rest of them. So again, to get here, I've gone over the most amount and down the least amount. In this middle here, it's always going to be square root of 2 over 2, but of course this one's negative square root of 2 over 2, just like this one was negative a half to go down. And then over here, the smallest one was over, and then down was negative square root of 3 over 2. Then over here, we have negative a half to get to this point here, and then negative square root of 3 over 2. Next one is double negative, so negative square root of 2 over 2, and then also negative square root of 2 over 2. And then the third one is negative square root of 3 over 2, because we've gone over the most amount and down the least amount, so negative 1 over 2. And then filling in the last one, which of course you can just use the filled in unit circle now, but just understanding the pattern, you're going to go negative square root of 3 over 2, the most distance, and then up the least distance. And then over the middle distance, and up the middle distance, and then over the least distance, and then up the most distance. Alright. So what does that mean for identifying tangents or sines or cosines? That means that if I want sine of pi over 6, sine is the y value. So sine of pi over 6 is square root of 3 over 2. Sine of 30 is square root of 3 over 2. What your calculator is going to tell you is the decimal equivalent of square root of 3 over 2. But what we want is actually to keep them as those radians as much as possible. I was going to say radicals. Alright. So that is our unit circle, and of course on your formula sheet I do have one filled in. So this is the formulas that we've talked about so far, and then also a completely filled in nice unit circle, so you don't have to look at my scribblings or your own scribblings. Alright, so now we're going to do what I said earlier, which is use it. So sine of 270, remember that sine is the y value, so all we're going to do is go to our unit circle, and the y value of 270, so 270 is here, x would be cosine, sine is 0, so we get 0. Then we have tangent of 30. So tangent, we got to be careful, is actually equal to sine over cosine. So if tangent is equal to sine over cosine, that means I need sine of 30 over cosine of 30. And then I'd be able to find tangent of 30. So where's 30? Up here. So my sine is going to be square root of 3 over 2. My cosine is a half. And since they're both divided by 2, you actually don't need the 2's. You can think of it as flipping the reciprocal as well. And so it turns out that tangent of 30 degrees is actually just square root of 3. Alright, the next one works backwards. So now they're saying cosine of what degree or what radian is going to make negative square root of 2 over 2. And so this is kind of an interesting one because there are two answers. So when is the x value negative square root of 2 over 2? That's going to be right here at 315 degrees, but also right here at 225 degrees. So it does get to have two answers. In fact, it actually has infinite answers if you think about it being in a circle. But the answer is going to be 225 and then also 315. You can, of course, write any of these in their radical form, their radian form if you would like, but right now it's probably easiest with degrees. And then the next one is asking you when is cosecant negative 2. So remember that cosecant is the flip of sine, so we're basically asking when is sine of something going to be negative 1/2. So you got to think about what is the opposite or the flip of what's happening. So we need a sine of negative 1/2, and as we look in here, when is a sine negative 1/2? That's going to be at 120, and then also at 240. All right. Then our last examples actually are for you to solve for x. So this is kind of reviewing back to when we would use sine, cosine, and tangent inverses to solve. So if this is our theta where we're standing, what they're giving us is the opposite, and then they want us to find the hypotenuse. So which of Sohcahtoa do we use to find that? Well, if we have opposite and hypotenuse, that's going to be cosine. So we know that cosine of 34 is what we're talking about, and it's going to equal 15 over x. The best way that I have for solving these is doing a proportion. So if we multiply 1 times 15 and then divide by cosine of 34, we should get our x value, that cross multiplication. This is also when we need to remember that if you're using degrees, you need to be in degree mode. So make sure that you are up there checking your mode and that you've highlighted degree. So x is going to be 18.09. It doesn't have a unit, so there you go. And then the last one, if we're standing here at the theta of 43, we have an opposite and a hypotenuse again. And so we're going to do cosine again of 43. And that's going to equal our opposite of x over hypotenuse of 14. Again, proportion, we're going to multiply 14 times cosine of 43. Divide all that by 1, which isn't really going to change much. And so we have an x of 10.24. Alright, so that is hopefully what we have, especially since we're going to work on an assignment now. So trig and the unit circle. Very exciting.